The next video is using properties of logarithms to re-express a logarithm statement without using multiplication, exponents, and powers. And what they're saying here in these directions, the properties of logarithms provide a way of expressing logarithmic expressions in forms that use simpler operations. We're going to convert multiplication into addition. We're going to convert division into subtraction. We're going to convert powers and roots into multiplication. So I'm going to show you how this works and what they're thinking when they ask you to do this. Remember, all these are contrived problems to help you practice getting used to or learning your properties of logarithms. So here's the first statement we're looking at. And I'm just going to rewrite it. I always like to rewrite log of 13 of 6 times a cubed times b times c to the fourth. Now, according to those directions, we want to replace multiplication with addition. We want to replace powers with multiplication. So what we're thinking about, and I'm thinking in particular, is there's a lot of multiplication being done in here. All the multiplication means that we have a power rule here. A product rule. The product rule says the log of a product is the sum of the logs. So this thing can be broken up into the log of 13 of 6 plus, since we hit a product, now it's plus the log of base 13 of a cubed. Now I hit another multiplication sign, so plus the log of base 13 of b. Then I hit another multiplication sign, so it's going to be plus the log of base 13 of c to the fourth. Now what I've done is I've traded in all the multiplication for a simpler operation, which is addition. The other thing they want us to get rid of, we shouldn't have any powers in here because any powers can be written as multiplication. So there's nothing to simplify in the log of base 13 of 6, but this one can be used, and we can use a power rule on this one. So this series is going to be power rules. So the log of a power is the power times log, so plus 3 times the log of 13 times a, plus, there's no power rule to be applied on the log of base 13 of b, but there is a power rule we can apply to our last term, and that's going to be 4 times the log of base 13 times c. So what they're asking us to do is get rid of all the multiplication substituted in for addition and make sure we get rid of the powers and exponents and substitute in for those multiplications. So we're going down to a lower level of operation. The next one, we got the natural log of 3y plus 2 all over 4 times the cube root of y. Okay, there's two things that strike me immediately. Number one, I see division. So as soon as I see division, I'm thinking of a quotient rule. So I'm going to apply the quotient rule right away. The quotient rule says the log of a quotient is the difference of the logs. So it's going to be the natural log of 3y plus 2. You notice I put those in parentheses because this was in the numerator, and a fraction bar is a grouping symbol. This numerator is the argument of the logarithm. So minus the natural log of the entire denominator, which is 4 times, and I'm also going to convert the cube root of y into y to the 1/3 power. Okay, pardon the interruption. Got a little phone call I got to address. All right, continuing with this idea, we want to turn all of our division into subtraction. We want to turn all of our powers into multiplication. So, and we also have a multiplication in here, so we got to get rid of the multiplication converted to addition. Now, what's going to be tempting is some people are going to look at this and think that they can do something with the 3 times y, but because this was in a grouping symbol with the fraction bar, this 3y plus 2 is a single argument, and there's nothing that we can apply to this, so this has to stay intact. The natural log of 3y plus 2. That's an inviolable argument. There's one way of saying it, and I didn't say it quite right, but you can't violate the argument. Leave it alone. So this one we can because we've got the log of a product. So minus the natural log of 4. And I got to be careful with this because I want to subtract all of this. The natural log of 4 plus the natural log of y to the 1/3. Okay, now in that step, I've used a product rule. The log of a product is the sum of the logs, so I traded the product in for the sum. And now the last thing I'm going to do is trade in our power for the product. So the natural log of 3y plus 2 minus the natural log of 4 plus 1/3 the natural log of y. And that one was a power rule. And we could do one more round of simplifications, and we could get rid of the brackets. We'll do the natural log of 3y plus 2. Then we're going to distribute our negatives, so it's minus the natural log of 4. Then it's going to be minus 1/3 the natural log of y. So that's what we're trying to do in those examples. We're trying to break them all down into the simplest possible operations that we can.